Hello, knowledge seekers. In this episode of 20-Minute Books, we're delving into the captivating realm of advanced computing with quantum supremacy. This insightful 2023 release renders the complex subject matter of quantum computers approachable and comprehensible for a general audience. The book skillfully navigates through the evolution of the traditional computer and ventures into an era where quantum computing boldly addresses humanity's most formidable challenges that our current supercomputers cannot resolve. Penned by esteemed physicist Dr. Michio Kaku, this book comes from a mind that once assembled a particle accelerator for a high school science fair. Dr. Kaku not only epitomizes scientific ingenuity, but also stands as one of the luminaries in his field. As both a co-creator of string field theory and a professor of theoretical physics at the City University of New York, he has broadened horizons with international bestsellers like Hyperspace, Visions, and Beyond Einstein, making him an authoritative voice that guides us into the mysteries of quantum mechanics. Quantum Supremacy is perfect for individuals who are intrigued by the potential of quantum computers, those who are curious about the fundamentals of physics, and forward thinkers who are eager to explore the impending technological revolutions. Join us as we uncover the quantum leaps that are reshaping our digital landscape and propelling us towards a new horizon of computational prowess. Quantum Supremacy: How the Quantum Computer Revolution Will Change Everything. Introduction. Unlock the secrets of quantum computers and their impact on the future. Have you ever stumbled upon terms like parallel universe or Schrödinger's cat and felt they were just whimsical concepts from the world of fiction or esoteric episodes of The Big Bang Theory? Well, it's time to pull these ideas down from the shelves of mystique and place them squarely in the realm of the imminent future. Quantum physics may sound like a complex puzzle reserved for academics and sci-fi enthusiasts, but it's becoming increasingly relevant to us all. It's time to prepare yourself for a paradigm shift in how we perceive the universe and our technology. The fantastical quantum realm is not reserved for theoretical debate. It's a frontier being charted as we speak, shaping the future of computing and, by extension, the fabric of our daily lives. Imagine a world where the limits of data processing are not just stretched but entirely redesigned. That's the world where quantum computing stands poised to take us. With potential leaps in energy efficiency, medical breakthroughs, and financial models. The quantum computer isn't a distant dream. It's a revolution on the horizon. This narrative takes you on a journey from quantum computing's nascent stages to its burgeoning power and limitations as they stand today. We'll navigate through the evolution of computing that has ushered us to this thrilling juncture, and, as we explore the profound implications of quantum computing across various sectors, you'll see why it's essential that everyone, not just the tech-savvy, pays close attention to these monumental strides. Part 1. A Quantum Leap Beyond Supercomputers. Picture this: a world where today's most advanced supercomputers might as well be using abacuses compared to the new kid on the block, the quantum computer. This isn't the script of a sci-fi movie. It's the reality that unfolded in 2019 when Google unveiled Sycamore. This pioneering quantum computer cracked a complex mathematical challenge in a mere 200 seconds, a feat that would leave even the fastest traditional supercomputer huffing and puffing for 10,000 years. The key to understanding quantum computing is to first abandon the notion of traditional bits, the digital on or off currency of computing, and embrace the concept of the qubit. Sycamore operated on 53 qubits, and at the time it was the titan of computation. Fast forward a couple of years, and quantum computing is turning into an international racetrack, with China's Quantum Innovation Institute claiming to have a machine that's a staggering 100 trillion times faster than supercomputers, thanks to its 113 qubits. IBM, not to be outdone, unleashed the Eagle with 127 qubits, and shortly after, the Osprey flying with 433 qubits. This is what's known as quantum supremacy, the point at which quantum computers outstrip digital counterparts at certain tasks. And believe it or not, we are just at the dawn of quantum potential. Quantum computing, with its myriad methodologies, runs the gamut from entangled atoms to utilitarian light beam information transport using an arrangement of mirrors. Researchers are on a quest to streamline this tech. Though we stand years away from quantum solutions for real-world conundrums in diverse domains like medicine, energy, and security. Don't be fooled by the current gap, though. The age of silicon is gearing for its curtain call. Moore's law, the revered prediction that transistor counts on microchips double every year and a half, is approaching its twilight. If we stick to silicon, digital computing is hitting its ceiling, but quantum computing has yet to begin its ascent, offering unrivaled processing velocity and the prowess to tackle complex problems by analyzing numerous solutions simultaneously. At the heart of quantum computing's might are two principles: superposition and entanglement. Superposition enables a quantum computer to consider all possible solutions at once, while entanglement keeps particles in a shared state even when separated by leagues. So why hasn't the quantum computer landed on every desktop and in every pocket? The answer is coherence. The atomic balance needed for quantum machinery to function is delicate as a house of cards. A slightest nudge from their frigid state of absolute zero can cause a collapse. Yet, optimists find solace in nature, where coherence thrives at comfortable temperatures. Take photosynthesis, for instance. Researchers are decoding nature's blueprints, hoping to replicate this naturally occurring coherence within our computers. But before we dive into the burgeoning applications and the future quantum computing promises, let's rewind the tape and explore the milestones that led us here. Part 2. From Ancient Gears to Quantum Frontiers. The Evolution of Computers. The odyssey of computing began in an era shrouded in antiquity and has spanned over 2 millennia to reach the cutting-edge quantum era. Imagine this. Nestled within the wreckage of an ancient Greek trading ship, resting off Antikythera's coast, lay a curious bronze artifact. Discovered in 1901, this device befuddled researchers for decades, evading identification until modern technology, such as X-ray imaging and CT scans, revealed its secret. The Antikythera mechanism, as it's now known, was an astonishingly sophisticated tool, simulating celestial bodies and forecasting astronomical events with precision that would remain unmatched for centuries. Quantum computing aims to replicate such a level of detailed simulation, venturing far beyond celestial mechanics to the world at the quantum scale. Its purpose? Tackling problems that have mystified humankind for eons. After the Antikythera mechanism, there wasn't a significant stride in computing until the 19th century, when Charles Babbage conceived the first digital computer, and Ada Lovelace, the progeny of Lord Byron, pioneered programming. As the 20th century dawned, pivotal figures emerged, catalyzing quantum leaps in computation. Max Planck dared to challenge Newtonian physics, laying the groundwork for what would blossom into quantum mechanics. Erwin Schrödinger took up the baton, weaving Planck's constant into his iconic wave equation and philosophizing about the enigmatic nature of electrons through his cat-in-the-box thought experiment. The mid-20th century heralded Alan Turing's conception of the Turing machine, the blueprint of modern computing that played a pivotal role in decrypting Nazi codes, significantly influencing the outcome of World War II. This era witnessed Richard Feynman's path integral formulation materialize, simplifying the complexities of quantum pathways and reinforcing the capability for quantum particles to explore every theoretical trajectory. As these brilliant minds laid the foundations of quantum science, the groundbreaking multiverse theory proposed by Hugh Everett seized our imagination. suggesting that every possible reality might exist alongside our own. This conjecture, which fuels the fanciful multiverse narratives in popular culture, is also a cornerstone of contemporary quantum theory. Thus, the legacy of these intellectual titans propels us forward, hurtling towards a future where quantum technology might redefine everything we know about computing power. With their monumental contributions in mind, let's explore how the advancements in quantum mechanics might crystallize into life-altering applications in the days to come. Part 3. The Duality of Discovery, from Fertilizer to Quantum Futures. Advancements in science and technology have long treaded a tightrope between benevolence and devastation, a dance exemplified by the legacy of Fritz Haber. In 1918, he was lauded with a Nobel Prize in chemistry for a procedure that turned nitrogen into nitrate fertilizer, igniting a green revolution that fed billions. Yet the same mind that helped nourish the world also birthed chemical warfare, leading to incalculable suffering through conflicts such as World War I and subsequent atrocities. Today, quantum science is challenging Haber's resource-intensive nitrogen-fixing method, marking a new era of exploration into the fundamental constituents of life itself. Let's consider two seminal instances that propelled our comprehension of life's molecular mosaic. In 1952, Stanley Miller's emblematic experiment, with a concoction mimicking Earth's primordial landscape and a spark of electricity, yielded amino acids spontaneously. Complementing this was the recent revelation that similar building blocks may be scattered across space, possibly deposited on Earth through extraterrestrial arrivals. The puzzle pieces clicked more definitively into place with the work of Francis Crick and James Watson, building on Schrödinger's theoretical musings, when they unveiled the enigmatic double helix, the DNA molecule, a key to life's complexity and diversity. Armed with insights from these monumental findings, we've come to grasp the mechanisms channeling the energy that breathes life into our world. Nevertheless, hurdles abound. Much like Haber's method, our pursuit of clean energy often relies on paradoxically unsustainable methods, while scientific revelations still emerge from systematic guesswork rather than clear-cut calculation. Enter quantum computers, the possible champions of a brighter, cleaner tomorrow. With the power to resolve intricate quandaries such as efficient nitrogen fixing or flawless solar energy capture, quantum machines could spearhead a second green revolution. We stand on the precipice of a future where quantum technology harvests sunlight with deft precision and tackles biochemical challenges with newfound grace, hopefully ushering in an age where scientific progress is unfettered by its darker twin. Part 4. The Quest to Conquer Complex Diseases with Quantum Technology. On a chilly December day in 1971, President Nixon famously heralded the onset of a medical crusade against cancer with the National Cancer Act. Decades have passed, and the foe proves formidable still. Cancer has resisted a clear resolution. The challenge cancer poses lies in its devious origin. It's not an external antagonist, but a traitorous transformation within our own cells. When cells that should retire continue to divide uncontrollably, cancer emerges. This cellular betrayal is echoed in other self-inflicted diseases we wrestle with. For instance, the tragedy of COVID-19 often stems not from the virus itself, but from the body's overzealous immune response known as a cytokine storm. Autoimmune diseases manifest similarly, with the body's defensive arsenal mistakenly targeting healthy tissues. And then there are the enigmatic prions, rogue proteins that betray their form, inciting a cascade of misfolding across the brain, fostering afflictions like Alzheimer's and other neurological storms. The riddle of why proteins tumble into such chaos remains unsolved, and with it, so do these illnesses. Embedded within humanity's timeline is a legacy of medical feats, sanitation, antibiotics, vaccines, enriched nutrition, all extending the human lifespan from a meager 30 years to a robust 70, simultaneously elevating the quality of existence. But let us not forget that this ascendancy in health has historically been a dance of trial and relentless error. Today, standing at the intersection of medicine and technology, quantum computers offer a glimmer of transformative hope. As we wrestle with the Gordian knots of diseases like cancer and Alzheimer's, with their tangled web of causative strands, it may well be the quantum leap that equips us with the blade to slice through. These marvels of computation promise a future where, through their ability to process myriad variables and intricate data, once insurmountable medical puzzles might yield to the relentless power of quantum logic. Part 5: Tackling Climate Change and Cosmic Mysteries with Quantum Aid. As we shift our gaze towards the current and existential threat of climate change and the boundless mysteries of space, quantum computing emerges as a beacon of hope in both arenas. The Earth is undoubtedly experiencing a fever, its temperature rising from the relentless assault of human activities. The melting polar ice caps uncage vast quantities of the greenhouse gas methane, further stoking the fires of global warming. On another front, the polar vortex, a bastion of cold, densely packed air at the poles, is betraying its historically dependable nature, slinking southward and turning weather patterns topsy-turvy. Facing climate change is less about preventing the inevitable and more about dampening its wrath. As our conventional digital computers gradually buckle under the complexity of modeling Earth's atmospheric tantrums, quantum computers dangle a promise of deliverance. Their unparalleled ability to evaluate countless pathways simultaneously could furnish us with precise climate models and weather predictions, which might be pivotal in safeguarding humanity's future. Beyond Earth's atmosphere lies another frontier where quantum computers can prove indispensable. Understanding the volatile temper of our own star, the Sun. The solar flare of 1859 is a harrowing reminder of our celestial vulnerability, a time when the skies danced with ethereal auroras while earthly communications systems burned. A repeat performance in our era would spell technological apocalypse, hurling society into a pre-industrial limbo. Our current grasp of stellar mechanics is woefully inadequate, leaving us blind to the whims of our sun. Yet here, too, quantum computers could shine. By simulating these cosmic firestorms, we gain the foresight needed to shield ourselves from such stellar outbursts. On the hopeful horizon of energy, the alchemy of fusion, akin to bottling the sun's heart, is inching closer to reality. The triumph in December 2022, where a fusion reaction outshone the energy invested in it, was a tantalizing prelude to what's possible. But commercial fusion energy remains a distant beacon, its journey plagued by expensive and futile trial and error explorations. Once again, it's the quantum computer, the oracle of modern science, that holds the potential to carve a clearer and swifter path to harnessing fusion power. The implications are titanic. Mastering our climatic ballet and the celestial symphony can not only resuscitate our ailing planet, but might also propel us towards our destiny as an interplanetary species. Quantum computers, thus, stand as the architects of a future where life on Earth thrives and ventures beyond, reaching out to the cosmic sea. Final summary. The journey of quantum computers from conceptual musings to tangible powerhouses is a testament to human ingenuity. These marvels of modern technology are no longer the figments of imagination in the science fiction realm. They are real, operational, and evolving at an astonishing pace. Whether calculating probabilities at phenomenal speeds or exploring alternative computing methods, quantum computers represent a technological renaissance. This continuous march of progress owes its momentum to visionary trailblazers like Erwin Schrödinger, whose thought experiments questioned the very nature of reality, Richard Feynman, whose ingenious formulations upended traditional physics, and Hugh Everett, whose ideas of parallel universes expanded our consciousness to unimaginable dimensions. But this is merely the prologue. The implications of mastering quantum computing are as broad as they are profound. Imagine a second green revolution that feeds the burgeoning global population sustainably, or a world where the enigmatic menace of cancer surrenders to the precision of quantum processing. The potential is boundless, and the stakes have never been higher. Quantum computing is not a question of if, but when and how quickly this technology can eclipse its infancy to address the daunting challenges that we face. On this precipice of possibility, we stand ready to witness the unfolding of quantum computing's next act, an era where the deepest puzzles of our natural and technological worlds yield to the clarity of quantum thought. Thank you for joining me today on this journey of learning and discovery as we explored the insights of another thought-provoking book in our growing library of knowledge. If you've enjoyed our time together, please take a moment to follow our podcast, give us a 5-star rating, and share 20-minute books with other knowledge seekers. Your support truly means a lot. Don't forget to join me again in the next episode, where we will delve into another enriching book. Until then, happy reading and happy listening.